So with this video, we're going to actually create some freehand notes. In other words, we're not going to fill in a pre-made guided notes sheet. What you're going to do is actually take the sheet that I provided to you in class today, dealing with the lesson 9 notes on finding the sum of interior angles for polygons, and I actually want you to turn that page over. And anything that I'm talking about in this video, I want you to write in on the blank side. So you're going to take the lesson 9 notes. You're going to take the lesson 9 notes. You're going to turn them over to the blank side. And we're going to write some notes on finding the sum of interior angles for polygons. So I'm going to actually change the thickness of my pencil a little bit here. All right. So we just want to make sure we understand what that means. To find the sum, simply means to find the total. Okay, so find the total. So we're going to find the total of interior angles. Now, interior means inside angles, or angles inside the shape or inside the polygon in this particular case. And obviously we know what a polygon is. A polygon we know is closed. Oops. It has line segments for all sides. And we know no sides intersect. So what we're looking to accomplish or quickly investigate, or to lay the groundwork for investigating further in class, is finding out if there's an easy way of determining the total of all the inside angles for any type of polygon. Okay, so I hope you have all that written down. Now, what we'll do is actually create a simple little table. So what I want you to do is write shape, and we'll do a quick drawing. So we're going to give the name of the shape here, then we're going to draw the shape, and then we're going to write number of sides, and then we're going to say sum of interior angles, essentially the total of all the interior angles. So let's talk about quickly a triangle. We could draw a nice simple triangle like that. So we have a triangle. We know that's a polygon. That's the smallest of the polygons we can have, because a polygon must have at least 3 sides. And we should know that the sum is 180 degrees. That should be pretty common knowledge. Okay, so the next thing we'll move on to, if we add a side, so if we have 4 sides, just in general, we're going to have a quadrilateral. Now that quadrilateral could be a square, it could be a rhombus, it could be a rectangle, it could be a parallelogram, it could be a trapezoid. It's any 4-sided figure. No matter which of the more specific quadrilaterals it is, it will add up to 360 degrees for its interior angles. Now let's do one more. If we add one more side, we have 5 sides, we now have a pentagon. Now a pentagon, 1, 2, 3, 4, 5. It doesn't have to be exact, but we know it has 5 sides. Now I'm going to see if I can use some of the information I have already from what should be more common knowledge to maybe make a prediction about how many degrees the interior angles add up to, or what the sum of the interior angles is for a pentagon. So we know a triangle started with 3 sides and it had 180 degrees. Now, when we went to a quadrilateral, we added 1 side, and if we did the math over here, if we did 360 minus 180, we would discover that we added 180 degrees. So that's really important. So by adding 1 side, we added 180 degrees. So there's not a lot to go off of here, but we're going to make the assumption that if we add a side again, we're going to once again add 180 degrees. So what that means is I'm going to have to do 360 plus 180 and see what that gives us. So let's see, 0 plus 0 is 0, 8 plus 6 is 14. Whoops, I want to say adding there. 3 plus 1 is 5. So we're going to go out on a limb here and assume that if I add a side, I add 180 degrees. So we're going to make the conclusion or draw the conclusion that a pentagon gives us 540 degrees. So one strategy we have, though it may not be a very efficient strategy, is to, with every time we add another side to a polygon, we can add 180 degrees. That might be one way of figuring out the sum of interior angles, say, for like an octagon or for a decagon or for a dodecagon, okay? But another thing that I want us to consider, and another strategy, which is actually going to be the focus of our discussion tomorrow, is to be able to look back at anything beyond a triangle and cut it into a series of triangles. So if I take this quadrilateral and I draw a line through it, you can see there's a triangle on its own. There's one, and there's a second triangle there. There's 2. Now what we're not going to do is to cut it into even smaller triangles. So there's going to be some rules for if we're going to do this, okay? But we can clearly see that there's 2 triangles here. And what's interesting is we already know that a triangle adds up to 180 degrees. So it seems logical that 2 triangles at 180 degrees each would seem to equal 360 degrees. So let's see if we can investigate that a little bit further with the pentagon. So if I take the pentagon and I draw one line through, I cut there, and I draw another line through and I cut there, and I look to see if I can do that any other time without cutting through, without intersecting what I've drawn already for these blue lines. It looks like I've maxed out at 1, 2, 3 triangles. Now, again, we know that each triangle is 180 degrees. So what would happen if I took 3 triangles, 180 degrees each times 3? If I multiplied that, I would get 540 degrees. So another strategy we might want to look at in helping us find the sum of interior angles is to see if maybe we can cut these bigger polygons into triangles and then use what we know about the sum of angles of a triangle to work into that. So those are 2 strategies we're going to investigate further. Either looking at the pattern of how we change with the amount of degrees being added based on the number of sides, or looking at how we might be able to deconstruct these polygons into triangles and working from there. So that's where I'm going to leave you off. Make sure you have all this information marked down and refer back to it because there's a small Google form that I want you to answer to be prepared for tomorrow's continued discussion on this.